Good morning, ma'am.
Good morning, Nubia. So where is other persons? Only Nubia, Naresh, Ravan Kumar is present. Only 3 members.
They will come late, ma'am, as usual. We'll have to wait for 5, 10 minutes.
Good morning. Okay, can I start or we'll join continuously? No worry. Okay.
Only 3 members are there. We'll wait for 5 minutes, ma'am. Then you can start, ma'am.
Oh, okay. No problem.
Ma'am, next class, when you will be taking? At what time?
This is 11 to 12:30. Then next
Yes.
at 1:30.
Ma'am, you can take continuous class. No, it will be better. No, ma'am.
Oh, okay. No, your wish.
From 12:30 to 2, you can take.
Oh, okay. No problem.
Depends on others also, ma'am.
Oh, okay. Okay. That's why I'm asking. Okay.
You can just give a 15 minutes break. Then you can continue.
Okay. So Vasanti madam will take the class at 5 o'clock, 5 to 6:30. Only one class.
Yes, she just told me, ma'am.
Okay.
Time is little late.
Yeah.
Because it is Saturday, no, ma'am.
That's right.
Things also.
I'm so busy today.
Yes, ma'am. That class I'm not sure of taking, ma'am. Still, I'll try to attend that class.
Good evening. Okay.
Good morning, madam.
Good morning, Gurveer. Good morning. ఇప్పుడు జాయిన్ అయినావు
మేడం బండి
ఓహో ఓకే ఓకే కార్ లో ఉన్నావా
ఇక్కడ ఒక దగ్గర కుల్ఫీ మంచి అమ్ముతున్నాం మేడం. కుల్ఫీ తిందామని వచ్చినా.
ఇంత కూల్లో మీరు కుల్ఫీ తినడానికి వచ్చారా?
ఈ వింటర్ సీజన్ లోనే కుల్ఫీ బాగుంటుంది మేడం. మా ఊరికి వస్తున్నాం, మా రేయాన్స్ ఇద్దరు కలిసి వస్తున్నాం.
ఓకే. బయట చాలా కోల్ గా ఉంది. స్వెటర్ అన్న అయిపోయినావు బాబుకి?
మేడం
బాగా కూల్ ఉంది కదా బయట?
లేదు మేడం, కార్లో ఉన్నా మేడం, అందుకనే.
ఓకే ఓకే. అరే స్టార్ట్ చేస్తాను, జస్ట్ 1 minute వెయిట్ చేస్తా. ఇక సాటర్డే మాక్సిమం మెంబర్స్ ఐ థింక్ ఆఫీస్ లో ఉండొచ్చు కదా, మరి లేట్ అవుతుంది.
ఓకే మేడం.
ఓకే ఓకే దుర్గేష్.
Durgesh, it's dangerous to do like that, holding your phone and driving.
Yeah.
You are on mute, Durgesh.
What, madam?
It is dangerous to drive like that, holding your phone with your right hand and driving.
This one, no, just 2 minutes. There's not much traffic is there, that's why I'll just shut it down.
Oh, okay. Ma'am, it's such a nice weather, no?
Yeah. Cooling, very cooling nice.
Yes, ma'am. That is why we were going to go to the farm to stay for the night. But then ma'am said the class is that way. But I'll try to take it from car only, the class. Ma'am, in more 2 minutes you start, ma'am. It will be 11:10.
Yeah, okay. So who is Oppo A5s? What is your name? I think I don't know. So
Last time also this name was there, Oppo A5.
Yeah. So I don't know what is this is
Good morning, madam. I am Dalia.
Oh, yeah, Dalia, good morning.
Dalia, you are not Oppo A5.
Yes, I want to say that. I am not Oppo.
Okay.
I think it is Savanana, madam. Oppo A5.
ఎవరిది
Savanana.
శ్రావణ్ కుమార్ వేరే ఉన్నారు కదా శ్రావణ్ కుమార్ ఆల్సో యాడెడ్ అది ఎవరు మరి
Please tell your name, Oppo A5s.
I think Rajshekar Reddy sir, madam.
రాజశేఖర్ రెడ్డి సార్ అంటారా అరే కాదు
joins our class, ma'am.
Huh?
Rajshekar sir also joins our class.
No. I think he is a little bit busy right now.
Okay. This person is very shy to speak up.
Okay, no worries.
Anamika.
What is your name? Anamika. Okay.
Those who don't have name, they are called Anamika.
Okay.
Ma'am, start.
Okay, right. So today class is ozone depletion, right? So this is associated to this polar vortex phenomena, right? So you see here, the polar vortex is largely in stratosphere, right? And remember, stratosphere has maximum concentration of, you see this, chlorine. Sorry, ozone, right? So what happens in this Antarctica polar vortex? Let us understand the chemistry. You see here, the chemistry. So the chemistry of the Antarctic polar vortex, it has created severe ozone depletion, right? So remember, Antarctica has lots of ozone holes, as we know, right? So nitric acid in polar stratospheric clouds that reacts with chlorofluorocarbons to form, what is that?
Chlorine.
This chlorine. Right? So, you see here what is happening in 70 degrees. This 70 degrees south, so that is close to pole. So you find chlorine concentration here actually increasing, right? So what happens? The chlorine concentrations build up during the polar winter, right? So in the polar winters, chlorine concentration rise and due to this ozone destruction, right? So it starts happening. So when there is sunlight that returns in springs, right? So these clouds can only form at atmosphere. which are below minus 80 degrees Celsius, right? So remember, when it reaches the acute winter temperatures of minus 80 degrees centigrade, right? So that is when this chlorine composition leads to the depletion of ozone, right? So third one, see here, and since there is greater air exchange between the, what is that, Arctic and middle latitude, and ozone depletion at the North Pole. North Pole is much less severe than at the South Pole, right? So Northern Pole has lots of mixing of air, right? Because of this land and ocean distribution. So, but because so much of land area is not available in southern polar nearby, southern polar nearby. So not much of exchange of air happen. So mostly the concentrated air in the polar vortex remains there. It does not change as it changes in the northern hemisphere. So that's why, due to this persistently remaining chlorine, right? This chlorine, right? So actually it leads to more ozone depletion in the southern portion than in the northern portion, right? So accordingly, the seasonal reduction of ozone levels over the Arctic is usually, as it's called, what is that, ozone dent, right? So remember, there are two terms. What is that? First one is southern hemisphere, right? Southern hemisphere. So that is in the Antarctic belt. That is called ozone hole, right? Ozone hole. So because it is there larger, right? It is larger. So while it is just called a dent ozone, dent in the, dent ozone. The next, dent in the northern hemisphere or in the Arctic belt, right? Arctic belt. So that is the main reason. So these two terms, southern hemisphere and northern hemisphere. So now you remember that how this polar vortex phenomena that is also related to ozone depletion, right? So you see this process, ozone depletion process, right? So you can write what is the process of ozone depletion in your examination. We are asking, you can write these 6 steps, right? So first one, the ozone depletion process began when chlorofluorocarbons and other depleting substances, so those are emitted into the atmosphere, right? So, and second one, so winds efficiently mix the troposphere and evenly distribute the gases, right? So chlorofluorocarbons are extremely stable and they do not dissolve in rain, right? So just 1 second. The chlorofluorocarbons are extremely stable, right? And they do not dissolve in the rain. So after a period of several years, the ozone depleting substances, that is called ODS, right? Ozone depleting substances molecules reach the stratosphere, right? Stratosphere. And about how much? 10 kilometers above the Earth surface. Right? Then next, third one. So here, strong ultraviolet, right? Strong ultraviolet lights breaks apart this ODS molecules and chlorofluorocarbons and hydrochlorofluorocarbons and carbon tetrachloride and also methyl chloroform and other gases, right? So these gases are released chlorine atoms. And halogens also. Halogens and methyl bromide release, that is bromine atoms, right? You see here this one. And fourth one is, it is these atoms that actually destroy ozone. So not the intact ODS molecules. So it is estimated that one chlorine atom, remember this word, one chlorine atom, it can destroy over 1 lakh ozone molecules before it is removed from the stratosphere, right? Then next, fifth one. Depleted ozones, right? Here, depleted ozone allows more ultraviolet radiation to pass through the atmosphere. Then next, sixth one, more ultraviolet radiation can cause more skin cancers, right? So this is very dangerous. So some ODS, ozone depletion substances, including chlorofluorocarbons, hydrofluorocarbons, and carbon tetrachloride and methyl chloroform. So these are released, what is that? Chlorine atoms, right? So it is estimated that one chlorine atom can destroy over 1 lakh ozone molecules, right? That is before it is removed from the stratosphere, right? So here you see, so the biggest problem was the chlorine from a man-made compound. So that is called chlorofluorocarbons, right? So we observe this figure. So here chlorines bind with ozone to make oxygens, right? Oxygen and this chlorine monoxide. So then the loose oxygen atoms that bump the chlorine atoms out and freeing it to destroy more ozone molecules, and that cause a chain reaction, right? So the long lifetime of the chlorofluorocarbons, that is a big part of the problem. So they live anywhere between how much? 50 to 150 years. 50 to 150 years in our atmosphere, right? So in 1987, ozone levels had dropped by 50%, right? 50%. So this growing led to some of the fastest collective action on climate we have ever seen, right? So you see here, this picture. So after the chlorofluorocarbons ban, we began using, what is that? Hydrofluorocarbon, right? So these hydrofluorocarbons don't deplete the ozone layer, but they are a potent greenhouse gas that contribute to climate change, right? So since 2016, the Montreal Protocol was amended to include hydrofluorocarbons, and now they are being phased out too, right? But they are only one part of larger issue, right? Now, why ozone hole, especially in Antarctica or the South Pole? So anybody tell me what is the reason?
Polar vortex
Polar vortex is main reason, right?
Yes.
Okay. So, you see, colder temperatures over the polar regions, which have been shown to promote ozone depletion, right? So, while warming temperatures lead to increased ozone. So, years with warmer temperatures generally had smaller holes, while colder temperatures has large holes, right? So, you see here in 1995, so wait, where is my pen? 1995, one of the scientists discovered a massive loss of ozone layer in over this Antarctica. Because, you know, the one factor is the chlorofluorocarbons. So these are producing the reactive chlorines, right? So that breaks down ozone. But where do those chlorofluorocarbons come? Well, they are all over the world, right? So they come from mainly from where? Air condition.
Air condition.
Yeah, this is the important thing, right?
Aerosols.
Yeah.
Aerosols.
So air conditions avoid chestanta manchidi manamu. Okay. So they are all over the world, all over the air. So there are chlorofluorocarbons in the atmosphere. So that includes over 2%, right? So the very low winter temperatures in the Antarctica stratosphere, it causes, what is that? Polar stratospheric clouds. PLCS, right? Polar stratospheric clouds, that is to form. So special reactions that occur on PSCAs that combine with the relative isolation of polar stratospheric air allow chlorine and bromine reactions to produce the ozone hole in Antarctic springtime.
Ma'am?
Yes.
But in the southern part, it must be cold all the time, no? So why would they use air conditioners over there?
Not only air conditions. There are
in southern part maybe because of air conditioners, but in northern part maybe because of other things as well, ma'am.
Yeah, I don't know actually exactly, right? So it is very cool right now, but yes, they are using air conditions. Why? Because I don't know actually. Okay, then next.
But then there the degrees are in minus, no, ma'am?
Minus, yeah, right. But this is the main reason.
Okay.
But they are using right now.
I think it is not only for Antarctica, it is for common air conditioning.
Yeah, maybe.
Normal, different, this thing, what is called, other than polar region, it can be air conditioners.
Yes. That's what.
Yeah.
Equatorial region and mid regions.
Right. Right?
Yes, ma'am.
The next, the formation of ozone hole in Antarctica has been an annual occurrence, and it has been recorded for the last 40 years. And human-made chemicals migrate into the stratosphere and accumulate inside the polar vortex. And it begins to shrink in size as warmer temperatures dominate. So the Antarctica ozone hole, one of the deepest and largest gap in the ozone layer in the last 40 years, right? So now it has closed or not? Anybody?
It had reduced, ma'am, but then now again it must have increased, ma'am. It is bigger than Australia, no, ma'am? The size of Australia.
But now it has closed.
Yes, ma'am. After lockdown.
Yeah, not after. Yeah, right. So that is according to World Meteorological Organization, that is WMO. In the year of January 6th, 2021. I think this is the period, Corona period, right now?
Yes, ma'am.
So the annually occurring ozone hole over Antarctic, it had rapidly grown from mid-August and peaked at around 24 million square kilometers. One of the largest so far in early October 2020. 2020, this is the largest, right? So the expansion of the hole, it was driven by a strong, stable and cold polar vortex and it very cold temperatures in the stratosphere. So the same meteorological factors also contributed to the record 2020 Arctic zone ozone hole, right? Arctic ozone hole. Now, which is also closed right now, right?
Yes, ma'am.
So you see here some pictures. You see the difference between 1979 ozone hole and 1999, right? Variations, right? So you see 2019 ozone hole.
A violet color red, madam.
Actually, this is the small 79 low small.
I guess.
The yellowish color is that whole,
yeah, orange, yellowish color is the whole.
అంటే enlarge అవుతుంది అన్నమాట మనం జస్ట్ ఇక్కడ నుండి.
ఓకే ఓకే అంటే
కలర్ అర్థమవుతుందా జస్ట్. So abnormal weather patterns in the upper atmosphere over Antarctica dramatically limited ozone depletion in September and October 2019. That is resulting in the smallest ozone hole. You see here? Smallest ozone hole since 1982. So this report from NASA, right?
Yes, ma'am.
And also annual ozone hole reached its peak extent of 16.4 million square kilometers. So that is 6.3 million square miles on September 8th, 2019. And then stand to less than 10 million square kilometers for the remainder of September and October. So during years with normal weather conditions, the ozone hole typically grows to maximum area of about 20 million square kilometers. 20 million square kilometers, right? So it's great news for ozone in the southern hemisphere. It said, that is said, who is that? Scientist P.A.U.L. Paul Newman says, right? So it's a great news for ozone in the southern hemisphere. He's the chief scientist for earth sciences at NASA, NASA, right? But it's important, so he says, but it's important to recognize that what we are seeing this year, that is due to warmer stratospheric temperatures. It's not a sign that atmosphere ozone is suddenly on a fast track to recovery. So this news is saying about this, right? And this is the largest hole, ozone hole. So in the year of 2020, right? So to the reason, persistent cold temperatures and strong circumpolar winds supported the formation of a large and deep Antarctic ozone hole in the year of 2020, and it is likely to persist in the November, right? So this report from the NASA, so right, NASA. So on 20th September 2020, the annual ozone hole reached its peak area at how much? 24.8 million square kilometers. Roughly 3 times the size of the continental United States. Okay? 3 times. So scientists also detected the near complete elimination of ozone for several weeks in a 6 kilometer, how much? 6 kilometer high column of the stratosphere near the geographical South Pole, right? So this is 2019 is the smallest ozone hole record, and 2020 is the largest, right? Next, reasons. What is the reasons? Now tell me, what is the reasons for ozone hole?
Mainly CFCs, ma'am. Chlorofluorocarbons mainly.
Yes, is aerosols and
okay.
different kinds
the
of
ozone hole has developed because people have polluted the atmosphere, right?
atmosphere.
Chemicals containing, what is the chlorine, bromine, right? So the primary chemicals involved such are chlorofluorocarbons and bromine, other related halogen compounds, and also carbon tetrachloride and nitrogen oxides, right? So the chlorofluorocarbons in particular have been used for a wide range of applications, including the refrigeration and air condition, and also you see here foam packaging, right? And make aerosol spray cans, right? So just 1 second.
Ma'am, hello.
She has gone somewhere, Durgesh.
Oh.
Right. So because these chemicals are so inert, so they are able to stay in the atmosphere. So they are able to stay in the atmosphere that is long enough to be carried upwards to the stratosphere, where they can damage this ozone layer, right? So the actual processes by which chlorofluorocarbons.
Ma'am, manamu ozone generators nunchi artificial ozone can't we make?
చేస్తున్నారు కదా ఇప్పుడు రీసెంట్ అంటే లేటెస్ట్.
అదే so ozone layer ki for repairing of ozone layer can we apply this?
Yeah, can apply. సో అంటే రీసెంట్ గా సైంటిస్టులు అంతా చేస్తున్నారు, అది ఇంకా మనకు అప్డేట్ లేదు. మీకు ఎవరికన్నా తెలుసు?
ఎందుకంటే ఓజోన్ ఈజ్ ఆల్సో యూజ్ ఇన్ వాటర్ ట్రీట్మెంట్స్ కూడా కదా.
యా, వాటర్ ట్రీట్మెంట్
అంటే ఓజోన్ అనాలిసిస్ చేస్తారు కదా వాటర్ ట్రీట్మెంట్.
ఆహా, ఓకే. మీరు ల్యాబ్ లో ఉంటారు కదా, నాకు అంత తెలియదు దాని గురించి. మీకు తెలిసింటే చెప్పొచ్చు లేటెస్ట్ అప్డేట్ ఏంటి అనేది ఓజోన్ గురించి.
అంటే ఆర్టిఫిషియల్లీ ఓజోన్ జనరేటర్స్ కెన్ క్రియేట్ ఓజోన్
ఓకే
by high voltages by means of UV light and
okay.
Ade artificial ga can they repair the ozone layer which is depleting?
Artificial, okay. అంటే యాక్చువల్లీ నాకు కూడా అంత తెలియదు దాని.
అంటే nowadays they are also using artificial clouds for rain లేకపోతే they are creating artificial clouds.
In Dubai,
can we artificially make ozone and help it in this problem?
Okay. Don't know actually exactly. I don't know. Naku anta recent తెలియలే.
అంటే by ozone generators నాకు తెలుసు ozone generators can create ozone. కానీ ఆ high level దాకా can we create that ozone to repair it అని అది తెలియదు.
ఓకే. అంటే అంత హై అంటే మనకు ఎంత హైట్ ల వరకు వెళ్తుంది అనేది నాకు కూడా తెలియదు అది.
That's what madam. That's what.
So you see here more ozone and less ozone. So you see the whole globe, more ozone, it is showing color, red color, right? The next, warmer year and colder year, right? Next, now, what are the ozone depleting substances? So tell me anybody, what are the ozone depleting substances? Just now I told
chlorine, ma'am.
Chlorine and bromine.
Okay, right. So the ozone depleting substances generally contain, what is that? Chlorine and bromine, carbon and hydrogen, right? So in varying proportions, and these are often described by the journal terms halocarbons, right? Journal terms halocarbons, right? So chlorofluorocarbons and carbon tetrachloride and also methyl chloroform. So these are more important human produced ozone depleting gases, so that have been used in many applications, including refrigeration, air conditions, foam blowing and cleaning of electronic components, and also as solvents, right? So another important group of human produced halocarbons, that is the halones. So which contains, what is that? Chlorine, bromine, fluorine, and it have been mainly used as 5 existing uses, right? So these substances are effective ozone depleters for 2 reasons. What is the reasons? So the first is that they do not break down in the lower atmosphere. So they can remain in the atmosphere from 20 to 120 years or more. So unlike it, most chemicals released into the atmosphere at the Earth's surface, ozone depleting substances are not washed, right? So it back to Earth by rain or destroyed by other chemicals, which means they drift up into the stratosphere, right? Okay. So then next, second reason, second is that they contain either both chlorine and or bromine, and thus help the natural reactions that destroy ozone, right? So once they reach the stratosphere, ultraviolet radiations break up these molecules into that chlorine or bromine, right? So which in turn break up O3, ozone, right? So you see here, these are the ozone depleting substances, right? So that these are chemicals that destroy the Earth's protective ozone layer, right? So they are chlorofluorocarbons, hydrofluorofluorocarbons, and hydrobromofluorocarbons, and halones, and methyl bromide, and carbon tetrachloride, and methyl chloroform, and also bromochloromethane. So these are the important ozone depleting substances, right? So what did we use ozone depleting substances for? So you see the main uses of ozone depleting substances, that is include, you see here, chlorofluorocarbons and hydrofluorocarbons, right? So these are used in refrigerators and air conditioners, refrigerants in commercial, right? And also hydrochlorofluorocarbons and halogens. So these two are in using fire extinguishers, right? And chlorofluorocarbons and hydrochlorofluorocarbons. So they are used in foam. So the next, chlorofluorocarbons and hydrochlorofluorocarbons as aerosol propellants and methyl bromide for fumigation of soil. Right? And structure.
The CFCs, HCFCs, rocket propellants కూడా యూస్ చేస్తారా?
యూజ్ చేస్తాం. aerosol and rocket propellants, right? అట్లా కూడా రాస్తాం. మీకు ఇంకా ఏమైనా ఎక్స్ట్రా ఎగ్జాంపుల్స్ రిలేటెడ్ అంటే మీకు తెలిస్తే రాసుకోవచ్చు దీంట్లో. జస్ట్ ఐఎమ్ సేయింగ్ ఓన్లీ జస్ట్ 1 or 2 examples, right? Okay. Next, first one is chlorofluorocarbons, right? So you see here, so chlorofluorocarbons, that is called CFCs, right? So these are a group of chemical substances that contain 1, 2 or 3 carbon atoms and at least 1 atom each of chlorine and fluorine. So chlorofluorocarbons were first developed in the year of 1920s, that is to replace sulfur dioxide as a coolant gas, right? Sulfur dioxide as a coolant gas. In the year 1930s, they began to replace ammonia, right? Ammonia for cooling uses, right? So the non-toxicity and non-flammability and stability and also heat absorption effectiveness and them early respected as wonder chemicals of the 20th century. So in the late 1940s, they began to be used as the propellant in aerosols. So Durgesh also telling, what is that, Durgesh? ఇంకా ఏమో దేనికి యూజ్ చేయొచ్చు అని చెప్పావు కదా, propellant in aerosols కాకుండా
rocket propellant.
Rocket, right. So this use its peak in the late 1970s when chlorofluorocarbons was identified as an ODS, ozone depleting substances, and aerosols became the main target of public actions, right? The chlorofluorocarbons were also used in the production of packaging and insulation and also other foams. So in the year of 1980s, they were widely used as coolants in refrigerators and air conditioners. So as solvents in degreasers and cleaners, right? And that is to dilute sterilant gas mixtures and as blowing agents in the production of foams, right? And how long they stay in the atmosphere, these chlorofluorocarbons?
20 to 120 years.
You see here. So chemical name is CFC, chlorofluorocarbons 11. That is called trichlorofluoromethane and CFC 12. Right? So these are, you see, these 1, 2, 3, 4, 5. Right? So,
ma'am, we need to learn this.
Yeah.
Okay, ma'am.
These are the very important CFC 11, CFC 12, so and also 113, 114, right? So these are very important, right? So the next, hydrofluorocarbons. So these are also a group of chemical substances that contain, what is that? 1 or 2 or 3 carbon atoms and at least 1 atom each of hydrogen, chlorine and fluorine. So the hydrogen makes them less stable and therefore less damaging to the ozone layer, right? So this is the hydrofluorocarbons. So this is the lifetime of hydrofluorocarbons. These are the names, chemical names.
Okay. And what is GWP, madam? GWP, 100 years gross. ODP, GWP.
So that is global warming potential. So that is a relative measure of the warming effect that the emission of a gas it might have on the surface troposphere, right? So it is measured as a relative to carbon dioxide, right? Global warming potential, right? Ozone depleting potential. So ozone depleting potential, it means it is a measure of the capability of a particular chemical that is to destroy ozone. And
then units, madam, what is the units of ODP? Or it is a constant value?
Units.
Units.
Acha, దీని units అని ఇక్కడ రాయలేదా నేను?
Madam. ODP 0.0055.
Okay. ఇది నేను ఎందుకు రాయలేదు? మర్చిపోయినట్టు చెప్తాను లేదు ఇది ఇక్కడ రాశాను. ఓకేనా?
అంటే ఓజోన్ ది యూనిట్ చెప్పారు కదా మేడం. అదేనా?
ఓజోన్ ది డబ్సన్ కదా?
Dobson.
Right. Same Dobson unit.
So 0.055 Dobson.
Dobson units. Okay. Then next halogens, same. So this is group of chemicals compound that is bromine, chlorine, fluorine, right? And also bromochloromethane and carbon tetrachloride and methyl bromide and methyl chloroform and hydrobromofluorocarbons. Right? So these are the ozone depleting substances. Then next, ozone depleting potential. So what is the ozone depleting substances and potential?
Potential means
how much it can destroy.
Right. So ozone depleting potential is a measure of how much damage a chemical it can cause to the ozone layer compared with a similar mass of dichlorofluoromethane that is called CFC11, right? So with an ozone depleting potential of 1.0. So it is used as the base figure for measuring ozone depleting potential, right? So this is base figure, right? So the higher the number, the more damage a chemical it can cause to the ozone layer. Higher is it can cause the ozone layer, damage ozone layer. And bromotrifluoromethane. మీకు ఇవన్నీ తెలుసా దుర్గేష్? మీరు ఆల్రెడీ ల్యాబ్ లో చేస్తున్నారు కదా?
మేడం ఇవి తెలుసు.
ఓకే.
ఆల్కైన్, ఆల్కైన్స్
అవి తెలుసు. ఈ నేమ్స్ వస్తాయా మీకు ల్యాబ్ లో?
ఇది అంటే వస్తాయి మేడం, అంటే డిపెండ్స్ మేడం.
ఓకే.
హాలోజన్స్ అవన్నీ తెలుసు మేడం.
Okay. This bromotrifluoromethane that is called halon 1301. So it has an ozone depleting potential of how much? 10.0, right? And carbon dioxide, it is a natural occurring greenhouse gas, right? So it has an ozone depleting potential of, what is that? 0, only 0. Okay, you see the difference. So this is 1.0 and bromotrifluoromethane is 10 and CO2 is 0.
Ma'am, it still damages, no?
Yeah.
Okay.
So ozone depletion potential is measured relating to chlorofluorocarbon 11. It represents the amount of ozone destroyed by emission of a vapor over its entire atmospheric lifetime. That is relating to that caused by the emission of the same mass of chlorofluorocarbon 11, right? So now I'm asking questions. You see here. In which place the first ozone hole it was discovered? In which place?
In Antarctica, ma'am.
Antarctica.
Antarctica, right. So in which year the first ozone hole was discovered? I already told. Just I am asking. Tell me, which year?
Nine.
1985.
1985, right? So, which day is observed as Ozone Day, International Ozone Day? 16th September 1994, the United Nations General Assembly proclaimed 16th September the International Day for the preservation of the ozone layer, right? So who discovered ozone layer? That is, the ozone layer was discovered in the year 1913 by the French physicist. His name is Charles Fabry, Fabry, and also one of these scientists, Henry, Henry Buisson, Buisson. So these two French scientists are discovered by the ozone layer in the year of 1930, first, right? So ozone layer is presented in which layer? In which layer?
Stratosphere, no?
Stratosphere.
Right. Okay, this is troposphere and this is stratosphere, right? So this is the ozone depleting substances. So can I continue?
Chlorine and bro.
Yes, ma'am.
Okay. So kindly all of you log in another username and password. So I will post in your group. Just wait.